But even if at the end of the talk you decide, OK, fuck that, I won't use the paging library, what I'm hoping that you'll take from this is also how the paging library works under the hood. Because when we built the library, we took into consideration a lot of the problems that we know developers have. So if you understand also how the library works, you'll also see a lot of maybe tips or parts of the code that you can also use in your own implementations. And with this, I'll also try to make sure that you get some best practices when working with lists in Android. So let's get started. In general, when you're working with lists, we kind of have a sort of an architecture expectation. So we know that we have something like a repository that works with a data layer. In the data layer, we might have a database. So here, for example, we would be using Broom, where we would implement a DAO, where we're getting the list of users. And because we want to be notified when the users in the database are changing, we're returning live data from the database. And we're also working with the network. And then in the repository, we would expose that live data of the list of users further down. The view model will be the one that consumes the data from the repository and then expose it forward. And then in the UI, we would work with a list adapter. So in the UI, we would have a view model that would expose the live data. And then in the list adapter, we would display our data. So for me, this is the key, this list adapter class. So this was released in support library 27.1. Are you folks already using it? Hands up who's already using list adapter. OK, it's unfortunately less than I hoped. And I'm saying this because working with the list adapter actually brings in a few best practices. What I like most about it is the fact that it takes an immutable list. So this means that once you're passing in your list in the list adapter, you're not changing that list. And then the list adapter also provides animated updates. So if you need to, I don't know, remove or update some of your elements, those transitions tend to happen automatically. And also, the list adapter makes sure that the diff between the existing list and the new list is happening on the background thread. So more precisely, the list adapter would provide a submit list method. And there, you would pass your list of users, let's say. Your recycler view will be populated with that list of users. But then, when you have a new list, the updated list, so here, for example, we might have an item that was removed and an item that was edited. The list adapter takes care of all of that animation for you and takes care that the diff between the previous and the new list is done on the background thread. So in terms of the implementation, you would have a list adapter. You would observe your live data of users from the view model, and you would submit the list. And then, in your list adapter, you would create a list adapter based on the view type, the user object here, and the user view holder. And apart from this, you also have to implement a diffutil callback. So here, you need to define when the contents of two items are the same and when the items are equal. So based on this, the list adapter would know what it needs to update. And then you would bind the view holder. You would get your user object, a non-nullable object. And then you would work with it, and you would bind it and display it. So again, the fact that list adapter takes an immutable list, for me, this is the key. It means that, like this, you're forced to do any operations that you might need to do on modifying the list somewhere else away from the list adapter, preferably in the view model or on any of the other layers that are not related to the UI. So as a consequence, it means that, for sure, those kind of operations, you can move them on the background thread, so you're not blocking the UI, you're not producing any junk. And also, it means that you can unit test that. It's testing a list adapter, it's not that easy. But moving that logic somewhere in the view model or repository or some other classes that are small, that only have that single responsibility of creating that list, is going to be much easier. OK, so in general, when you're building a UI that displays a list, you'll end up having a series of challenges. So as I said, we would have a view model that, let's say, displays some contacts that would work with the database that's backed by the backend. So we said that we're interested also in the updates. So this means that our database would either expose a live data or an observable. So when we get some new data from the backend, that data would be put inside the database. Our list will, or our observable or our live data will emit with the new list, and that will be displayed. The new items will be added. Sounds quite simple, right? But the truth is that things are not that simple, because usually when we're getting all the users from the database, we might even have a ton of users. We have maybe, I don't know, 10,000 users when we only need to display a handful of them. So this means that the first challenge when working with list UIs is handling large data sets, making sure that you're not holding in memory all of that ton of data. Next, when you're working with lists, you have to touch multiple layers. It's hopefully never just the UI layer, but rather you have to go through all of them. So this means that whatever solution you would need to implement, you would need to touch all of them. Next, you want to make sure that whatever work you're doing, especially if it's a large list, you're doing on a background thread. Then, because we've added lifecycle-aware components, you want to make sure that things also happen lifecycle-aware. You want to make sure that you're not, I don't know, loading items when the list is not even visible. You want to make sure that you're doing operations that are respecting the lifecycle. And next, we know that we want to be flexible. Chances are that maybe one list that you display in one screen will actually behave differently or will come from different sources than a list that you display in another screen. So this means that whatever approach you take, your approach needs to be flexible. It needs to be maybe also consistent. It needs to apply to different scenarios, different cases. So this is actually what all of these challenges is what we had in mind when we built the paging library. So the paging library has several main components. And today I want to go over all of these components and see how to implement a paging or how to work with a paging library. Because of all of these challenges that we have here, you'll see that the paging library might seem quite complex. And I think one of these causes is because paging library wants to be simple to use for simple cases, but it also wants to provide the flexibility that complex cases need. So I will tell you a little bit how to implement it, but I will also tell you how things work under the hood. So like this, if you have to implement those complex use cases, you will know what to pick and choose and use in your own implementation. OK, so the paging library has two core components, a paged list that is backed by a data source. So this means that the page list will page your data in chunks, in pages, that will come from the data source. And the page list will request those items when needed. So we said that in our view model, we used a live data of a list of users. When migrating to paging, we just replaced that list of users to a page list of users. Then, in our DAO, if we had live data of a list of users, you'd say that, OK, I can just replace live data with a page list of users. But think about the page list. What are the items that we need to display? Do we need to display small items? So our pages, we need to display bigger items. So this means that our pages can be small. We only need to get, I don't know, 10 items on a row from our data source. Or our items are quite small. So this means that we would need to get, I don't know, 100 items from the database. So this element, like what is our page size, is important when configuring the page list. So to do that, we work with a data source. So the data source is the one that gets the data. And it needs to know, OK, how many items do I need to retrieve? So for that, we work with a data source factory. So this means that in the DAO, instead of returning a live data of a page list, we actually return a data source factory that gets as a parameter an int and the type of data that we're interested in. And because Room supports paging by default, it means that you can also do any sorts of complicated queries inside your database. So if, for example, your data actually comes from 2 different sources that are stored in 2 different tables, just do a join or do some whatever query magic that you need to do to directly get that data that you need to display. Then in the view model, we said that we will use a live data of a page list. And then we need to initialize it. To initialize it, we would use a live data, live page list builder that would get as parameters the DataSource factory. This is the one that we got from Room, and the page size. So here, for example, I set the page size to be 30. Then in the activity, instead of working with a list adapter, we would work with a page list adapter. And then in the adapter, instead of having a list adapter, we would have a page list adapter. And then you would still need to implement the same diffutil. So if you've already migrated to a list adapter, it means that the changes that we've made so far are quite minimal. We just changed from a list to a page list. But then we have another small difference in the bind, because the page list adapter works with nullable items. And you'll find out why nullable in just a second. Then, when we're building the live page list builder, we saw that the minimum amount of data that we need is the page size. But paging library wants to be flexible. So it also allows you to configure things more. So instead of just passing the page size, you can pass a configuration object. So here, you can also set the initial load size hint. So how many items will be loaded the first time when the list is displayed. By default, this is 3 times the page size. Next, you can set the prefetch distance. So also by default, this is the page size. But consider a situation where actually your data is backed from different sources, or you know that the network connection is not maybe reliable. So this means that you can set the prefetch distance to a bigger number. So even if the user hasn't really reached the end of the list, the next items can already be loaded, and you can just create a smooth user interface. And then the next one is whether you should enable placeholders or not. And here's actually what placeholders mean. So let's say that we start with placeholders is false. So this is our list. You can see that our scroll bar is actually quite big right now. It had only loaded that initial low size items, and that's it. So as we scroll and we get to the end, we get that sudden hit of the bottom. Then we're requesting new items, we get new items, and we see that that scroll bar now is a little bit smaller because we've loaded items in our recycler view. But if the placeholders are enabled, here's what happens. You see that by default, we already have the scroll bar being smaller because it's the right size for all the items that you need to display. So this means that once you're scrolling and you're getting to the items that haven't been loaded, you will see placeholders. So what paging will actually do is return null for these objects, because it knows that, hey, I know I have to get these objects. Something will be here. Let me get and fetch them. But this means that you will be able to display whatever items you need here. And then once they're loaded, the placeholders will be replaced with your actual items. So the placeholders come with advantages and disadvantages. So the good thing is that the user can scroll past what's loaded. So if you already know that you need to load 1,000 items, you only load, let's say, the first 20, but the scroll bar is already the right size, and especially if you have some quick lookup, it means that your users can already go to, I don't know, some items at the bottom, and they can quickly scroll. They will see those placeholders, so that interaction will be a bit more smooth. Yeah, the scroll bar looks correct from the beginning. And you don't need to implement a loading spinner to be displayed while you're requesting items. The negative here is that the items should be the same size. If you have maybe, I don't know, some social feed where the items have different sizes, it means that you won't really know what you should display for placeholders. You don't know what is the type of items that will come. So as a consequence, you'll have a bit of a strange behavior when you get from some default placeholders to something that has different sizes. And also, it means that you have to extend the implementation of your adapter and make sure that you also handle that null item case, and you provide a UI for that placeholder. And then finally, your data source needs to be able to count items, so it needs to know how many items it should display. If room is something that you're using as a data source, room already provides this by default, because you can do count items from a query. OK, but what about RxJava? What if you're not using live data and you're using RxJava? Well, instead of using a live page list builder, you can use a Rx page list builder. And instead of calling build, you would just call build observable or build flowable, depending on what are your needs. OK, now let's see a little bit what's actually going on under the hood. What are all the operations that the paging library is doing for you, so you don't need to? So we said that we have a repository where we're calling this live page list builder build. Also in this repository, we would have a reference to the data source factory. So when we're calling build, it means that the result of the build will be a live data of a page list. So for this, the data source factory calls create to actually build a data source. The data source is returned. And then the data source loads the initial data, so that data that we saw that we can set. Once this is loaded, a page list object is created that holds that initial data and the data source. So this is passed to the live data, and it gets all the way to the UI in the page list adapter, where we're calling submit list. So now our items are in the recycler view. We display them. But now we scrolled, and we got to the items that were not. So because the page list has a reference to the data source, the page list is just telling the data source, hey, I'm out of items. Load me the next page. And the next page is going to be loaded and displayed. But then, what if we change the data in our database? What if, let's say, we're adding or removing items? So this means that our data source is no longer valid. We don't have that, let's say, I don't know, 100 items that we just want to display 10 by 10 items. Something has changed there. The data is no longer valid. So we call invalidate on it. So let's say that an item was added in the data source. So in this moment, we are again calling, or the data source factory calls create to get the data source. Now we get the new version of the data source with that extra item being part of it. And then we load that initial data. But now we know what that initial data is. We've already loaded, we've already scrolled to, I don't know, 20 items in our list. So that initial data is just that data in the middle that needs to be displayed. We're passing this to the UI layer. And then after we're submitting the list, the page list adapter does that asynchronous diff and sees what actually has changed. And it will only display the items that will change. It won't keep in memory the things that have been loaded at the beginning. So under the hood, the page list looks like a live data of a list. You can construct it and configure it in the repository. And then the adapter is the one that handles the new page lists and internal updates. So paging provides several types of data sources: a positional data source, item keyed data source, and a paged keyed data source. So these are important for the cases when your data source is not room, but rather you have to implement your own data source. Maybe here you want to directly work with the network, or you're saving data in, I don't know, a file or something else. So depending on how your data looks, you will decide on which type of data source you want to build. So let's take them on a row. Start with positional data source. So this is the one where you would need to display something like the contents, like the contacts list. So the one where you can quickly look up the items of a specific letter. So this one, the positional data source, has the user only as parameter. And let's see what's happening actually there. So we have a page list inside our recycler view, and we have a positional data source with items. So the first method that it's called is load initial. That has several parameters. The first one is request start position, then which, because it's load initial, is probably going to be 0. Then the page size, the load size, and whether placeholders are enabled or not. So this method will be automatically called, and then in your implementation, you'll have to decide, OK, what does that mean for my API? It means that I need to request items from position 1. I want to request, I don't know, 30 page sizes, and so on. So we get the items. And when we get the items, we get several information. We get the data, but we also get the position. And because we enable placeholders, we also get the total count of items. And this means that our list is displayed, and our placeholders are also displayed. Then the user is scrolling, and then the load range method is called with the start position and the load size. So now you know you need to request to your backend all the items starting from position X and a total number of, I don't know, 100 items. Then you're getting the next data source. Now the callback just returns the data, and the data is automatically appended to the page list. But then once you're scrolling further, it will know, past the items that haven't been loaded, it will know to automatically call load range on the item that is being displayed right now. So this means that you won't need to load all of those items that the user just quickly scrolled past. So the load range is called, we get the data, and just the data that we need is being displayed. But what if our data is invalidated? Well, in this case, we get the new data source. And here, load initial is again called. But the requested start position will be the one depending on where the user is at the moment when this is being triggered. So again, this is something that the paging library calls automatically. What you need to do is implement the load initial. But you have all of the information needed to know what kind of request you need to trigger to your backend, for example. So then you get your new data, and then that data is replaced in the UI. Next, item keyed data source. So let's say that your backend gives you a list of usernames, all of them ordered alphabetically. So this means that you can uniquely identify, based on a list, what are the items that can be fetched before that item or afterwards. So just by having that key, just by having, I know, for example, here, just by having Ruby, it knows how to load the items before Ruby. And just by having Sandy, it knows how to load the items after Sandy. So it's all based on a key. Given that it's based on a key, it means that we have as parameters the string. In our case, we set string as a key, and the item that needs to be displayed. So here's what's happening now. We have an item key data source, and load initial is called. But unlike the positional data source, we get the requested initial key. So this is the key based on which we can trigger our request to the backend. We get the requested load size, and whether placeholders are enabled or not. So then we get our data back, we display it, we continue scrolling, and then based on that last item that's being displayed, we get the key from that last item, and then we know how to implement a load after method based on that key. We get the data back, and the data is just appended at the end, and the user can scroll and see the rest. Again, as we're scrolling, based on that key, we can load after and get more data. But then if the data source is invalidated, then we get a new data source. Again, load initial is called, but because, again, we know what the items are being displayed right now, then we would just use that top item key to get the data that needs to be displayed. We get the data, and we display it. And that's it. Also, if you're scrolling up, it means that you need to load the items before a specific item. So you need to implement the load before method. But here again, you know what's the key, you know what's the requested load size, so you know what to ask from your backend, if this is how your backend gives you the data. Next, page-keyed data source. So this is specifically common in APIs that provide you a next and a previous page based on a query. So this is something that the GitHub or the Reddit APIs are providing. Once you search for Android, for example, it will give you a set of results, but it will give you links to the next and previous page. So in the page key data source, we still have a string, which is that key that we need to look for, and the item that we need to display. So this means that right now, what we have is something like a linked list. So you have items that are linked to the previous items, and so on. So when you get load initial, right now we only have as parameters the requested load size, because it's the initial. There's nothing to point before or after, and whether placeholders are enabled or not. So as a response, we get the data, but we also get these links to the previous and the next page keys. So we know how to get the previous and the next pages. We display this. Once the user scrolls, then we get the load after method is called with the key for that last item that was added. So then based on this key, which can be the link to the next page, we know how to request the data. And in the response, we also get the adjacent page key, so that key for the last item, so we know how to load the following chunk of items. OK, but what if the data is invalidated? So this is actually something that will happen if you do things like pull to refresh. So in this case, again, load initial is called, but we have no initial key. But actually, there's no problem in this, because if this happens when you have a pull to refresh, then it's OK not to have that initial key. And then we're getting the items with the data and the links to the previous and next pages, and we display it. And that's all. OK, but what if your use case is a bit more complex? What if you're not working just with a database or just with the network, but rather you need to work with the database and the network? What do you do in these cases? Well, we know that these two work great together. And we know that this means that we can page from the backend with all the benefits of having a local cache in the database. It means that this allows us to work offline, to display the data still if the user is offline, and we're able to fastly resume our application, because we don't need to wait for a network request response to be received. We can just display the data from the database. And because we already have the data in the database, we can minimize the network traffic, saving the user's data. So the thing with the database and network is that in the first case, it tends to be simplistically implemented something like this. So we would have, let's say, a database and the backend. And then when we're connected to the network, then we're saying, OK, I'm connected, then I'll just get data from the backend. I'm not connected, I'll just get data from the database. And then when I also get data from the network, I'll also store that in my local cache. But this data switching problem has several problems. The first one is the fact that this connected state is a very big oversimplifying of things. What if packages were lost? What if you're requesting data from multiple sources? What do you do in those cases? What if individual requests succeed or fail? But also, it means that you're storing data in the database, and you're not really using it even if the local data is present. So you still do all of those network requests, even if you already have that data in the database. So the model that we propose is different, is always work with the database. So have the database as your main source of truth for data. So this means that only once you're out of data from the database, you would get the data from your backend. Once you get the data back, you would store it, and then your view model will just get the data from the database. Because you're using a live data, it means that you'll be automatically notified when there's new data in the database. So this model of data layering allows you to have a consistent data presentation. And it's kind of a simple process. You need more data, you load more data. That's all. And then it gracefully degrades on failures. So for example, if you're out of data and then you need to get data from the backend, and you don't have an internet connection, then it's easy to just handle that end of data or no new data retrieved. Similarly, once you actually get, network connection back, the data is going to be set in the database and then automatically will be displayed. So it's easier to also create these kind of like retry mechanisms, for example. And then optionally, you can refresh on observe. So this means that if you decide that actually every time you want to, you're opening the application, you want to refresh the data to make sure that you're always displaying fresh data to the backend, you can just clear the database and get the data from the backend, or just get the data from the backend then at the beginning and still count on the data from the database. So the database and network concept needs an out-of-data signal from the database. You need to know, okay, when do I need to request more data? And that means that once, this also means that you're triggering network load to the database. So this signal of I need more data is implemented in the paging library as a boundary callback. So in the boundary callback, you would work with your API and your database. And you would implement a page list boundary callback of the type of item that you're working with. So here, you will need to override a method like onItem@endLoaded. So this is the moment when we ran out of data in the database. It means that we need to request data from the network. So this means that here, let's say that we're using some executor, we're getting the data from the backend. Depending on what kind of page list we need, we know how the request would look like. So here, for example, I'm using a keyed data source. I'm using the name of the item as a key, and then I'm saying how many items I need. And then once I get the response from the backend, and if this is successful, I just insert it in my database, and that's all. And then you could wrap this into another is loading, let's say, check, just to make sure that you're not hitting this too many times and you're not requesting the same kind of data too many times. OK, so where would this fit? This boundary callback is something that you would set when you're building your live page list builder. So you would just set the boundary callback, and that's it. You would just call the usual build on the live page list builder. So we looked at how the paging library works. We saw that you can page data from the database, network, or both, and display that data inside the recycler view. This is actually just an extension of the observable list pattern. So you're working with live data of a list, actually, under the hood. Page list actually is just an extension of a list. You can by default just configure the page size, but it also allows you more complex configuration in things like prefetch or whether you want to have placeholders or not. And it has integration with Room, with live data, and RxJava. So you could start using the page list adapter. But if you're not still convinced of the paging library, at least start using the list adapter, because it comes with all of this model of immutability, of immutable data source, of a reactive model of something else setting the data to the UI. Thank you.